and welcome to Curved Graphs with Cubic Education. In this mini lecture, you will understand what different types of graph look like and be able to match a graph with its equation. So, we're going to look at linear graphs first. We've already talked about linear equations quite a bit. So, for example, here we have an equation which is y equals ax plus b. Now, if an equation is in the form of y equals mx plus c, which this is, so you've got something next to x and then you've got a number on the end. So if you've got an equation that just has one number in front of x and then a number on the end, it's a linear equation. There's no squares or cubes, there's no fractions, it's a linear equation. This is a positive linear equation where the number in front of x is more than 0 and it gives you a straight line going up in that direction. This one is still a linear graph, but it has the number in front of x is less than 0, which means your graph will go downwards like this. And this is obviously known as a straight line graph. So you just need to remember the way these equations are laid out. You've got a number in front of x and then a number on the end. A number in front of x and a number on the end. And y is always at the beginning. Okay? If y isn't at the beginning, you can rearrange it to get y at the beginning. The second type of graph that you need to be aware of is a quadratic graph. We've looked at these as well in more detail, but as you can see, it's a longer equation. You have a number in front of x, but you also have a squared value. This will always be squared with a quadratic graph. We then have another number in front of an x, and then we have a number on the end. The c always is a constant number on the end. Okay, so one number here with a squared, a number in front of x here, and then a c. If the graph is where a is more than 1, so this is not a negative, it will look like this kind of shape. Okay, with varying, it could be thinner or fatter with varying degrees of wideness. Now in this one, it's the same equation. You've got a number in front of x with a squared value, with a number in front of x here, with a number on the end. But this time, the number in front of x is less than 0, which means it's negative. In that case, the graph would be upside down. The line for a quadratic equation is known as a parabola. The third type of graph that we're going to look at is a cubic graph. With a cubic graph, it's anything with a cubed in it. So, just like a quadratic graph was anything with a squared in it, okay, a cubic graph is anything with a cubed in it. So in this case, we just have a number in front of x with a cubed, and a is bigger than 0, meaning that the number in front of x is bigger than 0. It's not a negative. In that case, you'll get a graph that looks a little bit like this. Okay. Here we have an x cubed graph, so we have a number in front of x with a cubed. We then have a number in front of x with a squared, but it's still a cubic graph because there's a cube in it. Then we have a number in front of x, and then we have a number on the end. And also it's bigger than 1, so it's not a negative. So this time you'll get more of a curvature to the graph. This is more kind of like up, straight, and up. This one doesn't have a straight section. It just goes up, down, and then up again. It doesn't have this middle bit here. Okay? Now here we have a similar type of graph to this one, but it's negative this time. It's below 0. So we still have the cubed, but this time it will be the opposite way around. So it'll be still the same shape, but the other way around because it's negative. And then here we have y equals ax cubed. So we have our cubed value, same exact as this one actually. We have our bx squared, so we have a number in front of x and squared, a number in front of x, and then a number on the end. This time though it's less than 0, which means it'll just be the opposite way around. So you've got this one which is positive and this one which is negative. All you've got to do is try and kind of link the equation to the graph. The final one we're going to look at is a reciprocal. A reciprocal is a fractional graph. So here we have a number divided by x, where the number above x, or in this case in the fraction, is greater than 0, and we have something that looks like this. You don't need to know about this in detail, you just need to remember that if a graph has a fraction in it, it will look like this. Okay? Here we have exactly the same equation, but this time a is less than 0, meaning it's a negative. So in that case, it swaps quadrants. Okay? The lines x equals 0 and y equals 0 are called asymptotes. Okay, so basically they reach as close as possible to the edges of the axes without actually touching it. So an asymptote is a straight line which the curve approaches at infinity, meaning it will never touch that line, it will never get to 0, but it will get as close to it as possible. But you don't really need to know about this kind of thing unless you're going to do A-level maths. You just need to try and remember that a fractional graph like this will look like this. So let's have a quick look then and see if we can recognise them. So we have A, B, C, D, E, F, G and H. I will show the answers, but if you'd like to pause the video and try and think whether it's a cubic, a quadratic, a linear or a reciprocal graph, you may. Okay, so if you've had a go, if you look at graph A, that is a quadratic. We know it's a quadratic because it's got this curve. B, we know is a cubic because it has a different kind of curve. C is also a quadratic, it's just negative because it's going the other way. D is also a cubic and it's negative because it's going the opposite way to this one. It's also the fact that it's probably got more values because it's going down and up, whereas this one just goes straight across and up. This one again is a positive cubic graph, but again more values because it's very curvy. Here we have a reciprocal graph because it's in the two quadrants like that. Here we have another cubic graph, and then here we have another reciprocal. Now, looking at the equations we have down here, let's try and match them to the graphs we have. Now, first of all, we know that this is an x squared graph. We can see here we've got 2x squared, which means it must link to a quadratic graph, and it links to this one. It's a minus 2x squared, which means we could have guessed that it went along with this minus or negative quadratic. Here we have a reciprocal graph because it's a fraction, so it must link to one of these. Here we have a cubic graph because we have a 2x cubed, but it has an x squared and a 6x on the end, meaning that it's either going to be this one or this one. Now, it's actually a negative graph, minus 2x cubed, which means it must link to this graph. This one is a very ordinary quadratic graph, x squared plus x minus 2. Well, there's only one other quadratic graph, and it's a positive one, so it must go to there. Here we have a negative 3x cubed graph, so we have a negative cubic graph. We have a negative cubic graph, but it's only got one value for x cubed, then it must go to this one. Okay, it's not that wavy. Here we have an x cubed minus 7x plus 6, meaning that it would go with a more curvy graph, such as that one. Here we have another reciprocal because it has a fraction, which means it must go to that one, and it's also negative. And finally, we have our 2x cubed graph, which is a positive graph, and a simple cubic, which means it must go to, it's meant to go to B, sorry. Okay, so that one's actually linked to this one here. Okay, so the graph here shows the line with equation y equals x squared plus x minus 12. Now, it's showing you this is the quadratic equation for this line, for this quadratic graph. And you need to find estimates for the solutions of the following equations. So you've got x squared plus x minus 12 equals 5, okay? So you've got the same exact quadratic line, but it equals 5. That means that we would go along where 5 is, and so we would go along here like this, where 5 is, all right, on the y-axis, okay? Because this has got to be y. This must be y because these are all x values. So this is going to be y. So 5 is on the end of your quadratic equation. You go to your y-axis, you go to 5, and then you would go across to the line, and then you would go down. So you're looking at about minus 4 point something there. And then you'll go across to this one and go down, and you're looking at 3 point something. So you can see we've got minus 4.6 for this one, and 3.6 for this one. So when it asks you to find solutions based on a graph, we always look at the end number if it's in this format, which it probably will be at foundation. We look for this number and we go to that on the y-axis, go along to the quadratic line and find the two numbers. Why don't you pause the video and have a go at x squared plus x minus 12 equals minus 7. Okay, if you've had a go at that, let's have a look. So minus 7. So we're going to go to minus 7, which is here. So if we look here, we have about 1 point something and then minus 2 point something. So we have minus 2.8 or 1.8. X will always have two values because you've got two parts to the graph. Whereas on a linear, like straight line graph, you'll only have one value for x. Okay, so that's everything you need to know about curved graphs. The main thing that you remember is what the graphs look like and matching them kind of to an equation based on whether it's an x, x squared or x cubed. Well done, thank you very much for using Cubic Education and I hope to see you next time.